To do direct substitution, simply plug the number in. If the problem says the limit as x approaches 3 of 2x, just plug 3 into x, and 3 times 2 is 6. It's that simple. And I pity the fool that can't do that.
The first technique to evaluate limits is going to be direct substitution. It's probably the most direct. You always check for it first. So in this case, we can plug 2 directly in. So 3 times 2, the result of this problem is 6. If you can put it directly in, just do so. So 3 times 2 squared minus 1. You do the exponent first. 2 to the second is 4. And you multiply before you subtract or add. So 12 minus 1. The result of this limit should be 11. If you can't do direct substitution, you need to try some of these other techniques. The second one we're going to do is factor cancel. You can do that with rational functions that involve polynomials. The third way is going to be multiplying by a common denominator and rationalizing. And L'Hopital's rule is a very useful technique. However, it involves derivatives, and we'll get to that after the chapter. So we're going to move to factor cancel. Okay, here you cannot put a 3 in because it gives you 0 divided by 0. That's called an indeterminate form. Infinity over infinity or 0 over 0 is indeterminate. So I'm going to factor this. Okay, we'll simplify. So this is going to be x plus 3 times x minus 3, and it's divided by x minus 3. These two factors will divide out, leaving me the limit of x plus 3 as x approaches 3. Now I can put it in because I don't have division by 0. So 3 plus 3 gives me the result of this limit to be 6. Over here we have another polynomial that we could factor. You cannot put 2 in because it causes division by 0. So we're going to see if this factors. The denominator factors into x plus 2 times x minus 2. It's called the difference of squares. The numerator is a trinomial. It's going to factor into 2x times x. Now if I put 2 in, this is the one that would have to cancel, so I'm going to assume it probably contains an x minus 2. Okay, 2x squared, this gives me negative 4x. I believe this would factor with a negative 1. So that's 2x squared, negative 4, negative 1 is negative 5x, and a positive 2. Cancel the common factors, and now substitute in the 2. So 2 times 2 is 4, minus 1 is 3. And if you put a 2 in the denominator, 2 plus 2 is 4. So the result of this limit is 3/4. Factor and cancel is a very common technique. We're also going to talk about rationalizing. To rationalize, you can always tell these, again, it's 0 over 0 in indeterminate form, but they have to involve square roots. So you're going to use something called the conjugate. Okay, the conjugate of a, think of this as a minus b times a plus b. So the conjugate of this numerator is the square root of x minus 2 plus 2 divided by itself. Now if you have a minus b times a plus b, those are the difference of squares, the result would be a squared minus b squared. So if a is the square root of x minus 2, a squared is going to be simply x minus 2. Minus, always use parentheses when you divide. And if b is 2, b squared would be 4. So if you simplify this numerator, it's going to become very conveniently x minus 6. In the denominator, you have all of this multiplied together. X minus 6 times the square root of x minus 2 plus 2. cancel the common factors. Now I have 1 over square root of x plus 2, x minus 2 in here. So I'll cross that out. 1 over square root of x minus 2, and then with the plus 2. Now what I need to substitute in for x is this 6. So if I put 6 in, I get 1 over the square root of 6 minus 2, which is the square root of 4, plus 2. So I believe the result of this is 1 over 2 plus 2, or 1/4. Rationalizing can be one of the more challenging techniques. Another technique is multiplying by a common denominator. Here's a fraction. Again, if I put it, it's a rational, no radicals, I can't factor it. If I put 4 in, I get a 0, I get 1/5 minus 1/5, so it's 0 over 0. So I'm going to multiply by the common denominator of the numerator, which is 5 times x plus 1 divided by itself. You have to multiply by a fancy form of 1. It's called the multiplicative identity. This way you don't change the value. If I multiply here, the x plus 1's will cancel, leaving me 1 times 5, which is 5. Minus, again, always use parentheses when you subtract. When you distribute to the second term, the 5's will cancel, leaving me x plus 1. So if we simplify this, you have 5 minus 1, which is 4, and a negative x. 4 minus x and x minus 4 are very similar. You just have to factor a negative 1 out and reverse the subtraction on one of these. So if I take a negative 1 out of the numerator, it changes the sign. This 4, positive 4 becomes a negative 4. This negative x becomes a positive x. Now it's going to cancel with the x minus 4 in the denominator. So if I cancel these, I end up with negative 1 over 5 times x plus 1. And again, we're doing the limit as x approaches 4. So if I put a 4 in, I believe the result is negative 1 over 25. The fifth technique is called L'Hopital's rule, but we're not going to be able to use that until we learn derivatives. I hope this helps with evaluating limits. Good luck.